This stats review is on exploring bivariant data. Bivariant means you have two variables. So that's what we're going to be looking at, the relationship between an X and a Y. Just a couple things to point out. Bivariant data is two different variables collected from each item in a study. We often want to investigate the relationship between two quantitative variables. If two quantitative variables have a linear relationship, then we can measure the strength of that relationship with a linear regression. And these are just all examples of quantitative variables. You can't do an L1, L2 with qualitative variables. On the AP exam, there are two commonly used measures to summarize the relationship between two variables. You've got a scatter plot, which is a graphical summary, and then you've got the correlation coefficient, which tells you how strong the relationship is. Looking at the graphical summary, you can also look at the strength. Correlation coefficient just puts it in terms of a number. A scatter plot is used to describe the nature, meaning is it a positive relationship, a negative relationship, the degree, that's how strong it is, and the direction of the relationship between the two variables. Going to draw an X and a Y axis, figure out what you need to go up by each one and plot the dots. They're not going to ask you to draw a scatter plot on the AP exam, but they'll give you some to interpret. So down here, here's what a scatter plot can tell us about the two variables. It tells you the shape. And really what we're looking for is if it's linear or nonlinear. It also tells us the direction. You can have a positive relationship, which means as one variable goes up, the other variable also goes up. A negative relationship, that doesn't mean it's a bad relation. It just means as something goes up, it causes something to go down, or vice versa. As something goes down, it pushes the other variable up. The strength of a relationship is talking about your R, which is your correlation coefficient, which is always in between 1 and -1. Both 1 and -1 are equally strong. 0 means it's extremely weak, no relationship. So it gets strong as it heads to 1, it gets strong as it heads to -1. Equal strength, just the difference between a positive relationship and a negative relationship. Then you should also understand that R and slope are going to have the same sign. So then you've got some examples here at the bottom. This one, the first one is just extremely scattered. There's no relationship. The second one, figure 26, you can see that there is a pretty good solid linear relationship. Figure 27, definitely a nonlinear that looks to be somewhat exponential. And 28 is nonlinear, could be quadratic, or it could be exponential with a little outlier out there. Figure 29 is a strong positive linear relationship. Okay, so strong because the points are really, really close together. They're close to the line. Positive because it's headed up, and linear because it's in a straight line. So 3 adjectives used to describe this relationship. And when you're describing that, you need to use all 3. The strength, the direction, and if it's linear or nonlinear. Figure 30 is a weaker. It's still positive, it's still linear, but it's a weaker relationship. This is a negative, strong, linear. This is a negative, weak, linear. Example 17, at the graduation ceremony of a large university, a random sample of 50 father-son pairs was selected, and the heights in inches of the fathers and sons were measured. So here we have a scatter plot. The line is where the son's height equals the father's height. So down here we have the father's height. So let's say he's 67 inches. Well, if the son was the same height, he would also be 67 inches. So you can tell that most of the sons are taller than their fathers. Notice from the plot there's a positive relationship. It's fairly strong, definitely linear, but in general, taller fathers have taller sons, and also sons are taller than their fathers. So two conclusions here. Taller fathers have taller sons. So if we look back, the taller the father, the taller the son. But we also notice that most dots are above the line where the sons equal the fathers, and that just means that the sons are taller than their fathers. And in this particular sample, every single son is at least as tall as his father. Okay, correlation coefficient, touched on this earlier. Numerical measures used to judge the linear relationship between two variables. Note the word linear. Correlations coefficients do not work well with non-linear relationships, and that's a great multiple choice question. Talked about R being in between a 1 and a negative 1. Okay, so when you describe it, you need to talk about the direction. Positive value of the correlation coefficient indicates a positive relationship. Negative value indicates a negative relationship. The strength, which we kind of already talked about. We talked about strong and weak. So you're going to always talk about the direction, positive or negative, and the strength, strong or weak. Correlation coefficients are usually computed using a calculator or by reading a computer output from popular statistics programs. Formulas to find R are included in the AP exam formula sheet, but they are time consuming. We just do this on our calculator, and it's just by plugging in your data and then making sure that your diagnostics is on your calculator. So pause the video, take a second, and type this data into your L1 and your L2. Okay, so you've had a chance to plug this information into your L1, L2, so I'm going to walk through how to see what the scatter plot looks like on your calculator. If you have the new calculator, the new operating system, it's really easy. You're just going to quit out of this and go stat and go over to calc. And remember, we don't use number 4, which is what you used in math 1. We use number 8. Okay, and then also notice that the B becomes your slope because he's the guy with the X, and your A becomes your y-intercept. So you're going to hit enter. Again, remember, I have the old operating system, but if you have the new one, it should say L1, L2, but then you should have a place where you see the word store regression equation, and you want to tell it to store it in your Y1. I'm going to show you how to get your Y1. If you have the old operating system, then right here on this screen, I'm going to put a Y1. So to get your Y1, you go to your vars button, and then you go over to YVars, and I want function variables. And your Y1 lives right there. So I'm going to hit enter. So for me, it pulls it up right there. If you have the new operating system, you want your Y1 beside where it says store. And then hit enter. Gives you your y-intercept and your slope and your r squared and your r. So there's your r. And then to see the graph, you need to turn your stat plot on. So I'm going to go second y equals. And on plot 1, you want to make sure that it's on. So if it looks like this, you just go over to on and hit enter. And then you want to make sure you're on a dot plot. And your X list should be your L1 and your Y list should be your L2. And then if you'll just go zoom, and what the storing does is the storing takes the equation and puts it into your Y1. And then I can go zoom 9, which is your zoom stat, and it shows you all your pieces of data, and it shows you your line of best fit. Okay, so if you ever needed to graph one, that's how you would do that. Okay, let's see. So we've got it all typed in. And we've done all that. We've graphed it all. And correlation coefficient, this just shows you that you have to go to your catalog and turn your diagnostics on. Some of you have the new operating systems. It's under mode. Gives you a big screen of a whole bunch of options to pick from, and one of them way down here in the bottom is diagnostic stats on or off, and you want it on. Once you've set it, it should stay on, but if for some reason you get to this screen right here, hold on. You get here, and you have your A and your B, but you don't have an R squared and an R, then that's how you get it back. But again, once you set it, should be fine. We do not clear calculators for the AP test, so once it's there, it should stay there. So that's how you get your R, and you can tell our R is 0.903. We did talk about what the R squared is. We'll review that here in a little bit, but that's how you get your R. So 0.9. So positive, very strong linear relationship. Okay, so now let's look at least squares regression line. On the test, sometimes they use the abbreviation LSRL to refer to a least squares regression line. Okay. The reason we want a regression line, which is what we just found for the heights, is so that we can predict what should happen given specific pieces of information. So a linear regression model or a linear regression equation is an equation that gives a straight line relationship between two variables. This right here, and they have this E, which is this error, which we don't use. That right there is on your formula sheet. So pause for just a second, grab your formula sheet, find this guy, get your eyes on him, and reacquaint yourself with him a little bit. Y is your dependent variable because it depends on X. B sub 1 is your slope, and B sub 0 is your y-intercept. Anything that's B sub 0 or anything that's sub 0 is going to be an initial value, and so that's your y-intercept. And again, we don't worry about E, so you don't have to worry about any of that. All right. The predicted value of, okay, AP tip, hold on. Be sure to distinguish between actual data values and predicted values. In the above statements, the words on average and predicted accomplish this goal. The predicted value of y for a given value of x denoted by y hat. You guys remember, we spent a lot of time worrying about if our y's had hats on them or not. If it has a hat, it is a predicted value. So y hat equals a plus bx. On our formula sheet, there's your y hat equals b sub 0 plus b sub 1 times x. Then you've got your formula for b sub 0. Go ahead and find him on your formula sheet. So I know that my b sub 0 is my formula for my y-intercept. X bar and y bar, those are just the averages of your L1 and your L2. B sub 1. Now I need B sub 1. B sub 1 is my slope. There's your formula for B sub 1. Again, it's on your formula sheet. Go ahead and get your eyes on him. Now R, we just talked about how to find R. S sub y is the standard deviation of your y's, and S sub x is the standard deviation of your x's. So once I have when I have my L1 and my L2, I need to do two variable stats because I need X bar, Y bar, S sub X, and S sub Y to be able to find all of this information. All on your formula sheet. Let's see. The least squares regression line, okay, this is important right here. I've seen a multiple choice question that looks like this. The least squares regression line is a line that minimizes the sum of the squares of the residuals. Why do we square them? Because some of them are positive and some of them are negative. So we square them to make them all positive. So the least squares regression line is the line that minimizes the sum of the squares of the residuals. The line of best fit will always pass through the average of the x's, comma, the average of the y's. It will always pass through x bar, y bar. That will always be an exact point on your regression line, on your line of best fit. Coefficient of determination. That's your R squared. If you go back and look at your calculator, you can see that when it gives you all this information, it gives you an A and a B, which is your y-intercept and your slope, and it gives you an R, but it also gives you an R squared. That R squared measures the percent of variation in the y values attributable to the variation in the x values. It's denoted R squared, and it literally is R squared. It's always going to be between 0 and 1. Okay, so here we go. We're going to take this problem right here, and we're going to find the equation all by ourselves, all by hand. A random sample of 10 office assistants hired within the last 6 months was selected from a large company. Each assistant's experience in months at the time of hire and annual starting salary in thousands of dollars were recorded. The data is given in the table below. Now, if this is a multiple choice question, you L1, L2, you let your calculator find you the equation. That's easy peasy. But if this is a free response question, you have to find the prediction equation by hand, and you have to show your work. Okay? So, compute the slope for the line of best fit and interpret it. Okay, so here we go. Hold on one second. Let's finish. Let's read all the questions first before we dive in. B says it wants the y-intercept. C says find the equation of the least squares regression line to estimate the starting salary. D says plot the line of best fit in a scatter plot. E, predict the starting salary for an office assistant with 6 months of prior experience. What is the residual if a person is hired with 12 months experience? Compute the coefficient of determination and interpret it. Okay, and then also just to remember what extrapolation is. It sounds very painful, but it's just when you use the prediction equation to find a value outside the original range of x's. I think we did a problem that was like a Ford truck, and we were trying to predict, I don't know, I think it was like how many miles a truck had on it if it cost $30,000 or something like that. And you have to make sure that your values are within the range of the ones given. If they ask you to predict for a value that's outside, that's called extrapolation, and you can't do it. Okay. Okay, so here we go. Let's go back. And here's A. Let's compute the slope. Okay, so look on your formula sheet and find the formula for slope. Make sure you know if the slope is B sub 0 or B sub 1. And if you're not sure, look at the formula for the prediction equation. Your prediction equation, and I know the slope is always the guy with the x, so my slope is B sub 1. The formula for slope, okay, so now I need R and I need S sub Y and S sub X. Okay, so I want you to pause the video. I want you to go type this data into your L1, L2, and I want you to do 2 variable stats to get your standard deviation and your average for your X's and your Y's. And you also need to go and get your equation of the line because you need your R. Okay, so pause it, do both of those things, and then hit play once you're good. Okay, so here's what I have. I got my R to be 0.951. We're going 3 decimal places. I got my S sub Y to be 4.795, and I got my S sub x to be 4.185. So B sub 1, always show the formula first. Plug it in. Type that straight into my calculator. Again, going 3 decimal places. On this one, I'm going 4 because the first decimal place is a 0, and y'all know how I feel about that. Okay, so I have computed the slope, but then it says interpret it. Okay, now remember, this data is about office assistants who are hired and what they're making when they start based on their years of experience or their months of experience. Slope is always over 1. So this is a for every 1 more month of experience, the starting salary will increase by, now remember, your starting salary, your salary is in thousands of dollars. So 1, 2, 3. So for every 1 more month of experience, the starting salary will increase by $1,089.60. One more time. For every 1 more month of experience, the starting salary will increase by $1,089.60. Okay, part B wants the y-intercept. Okay, I'm going to go right back here and keep on trucking. All right, y-intercept. Your y-intercept is your B sub 0. That guy right there. So use your formula sheet and find your B sub 0 formula. And he is y hat minus B sub 1 x hat. Okay, so B sub 0 equals, all right, my y hat from when I did my 2 variable stats was 26.1. Check your calculator, find your y hat, and make sure it's 26.1. Minus, now my B sub 1 is my slope. Well, that was 1.0896. So if you screw your slope up, your y-intercept doesn't have a prayer. Times x bar. Okay, so go back and look at your calculator, look at your 2 variable stats. Your x bar was 5.2. Type this straight in. I got 20.434. Well, guys, this is a y-intercept. This is B sub 0. This is its initial value. So what does this mean in terms of these office assistants? Well, it means that the predicted, you have to make sure you use that word, the predicted starting salary with 0 months experience is, scoot your decimal 3 places, $20,434. You have to make sure you use that word predicted. Okay? All right, now C says find the equation to predict. All right, well, I got my slope and my y-intercept. So y hat, because this is for a prediction, is 20.434 plus 1.0896x. Now, I've just used variables in here, and I have to define my variables. Do y'all remember doing that? So y hat is the what? Predicted starting salary. And x is number months experience. Okay? D wants us to graph it. And again, pause the video and go practice graphing. Pause the video. It's already typed into your L1, L2. Get your equation, store it into your Y1, then go zoom 9, and it should pull it right up. Just remember, but now that you've turned your stat plot on, when you go back and do normal math or a normal graph, you need to turn your stat plot off. Okay, E says predict the starting salary for an office assistant with 6 months of prior experience. Well, let's make sure that's not extrapolation. 6 months. Well, the months go from 0 to 12. So 6 months is well within this range, so we're fine. So I'm going to use my prediction equation. And I'm just going to plug a 6 in for my x. Type it straight in. Do not lose the hat on your y. And I can say that the predicted starting salary for someone with 6 months experience would be $26,971.60. Okay, F says it wants the residual. I don't know if you guys remember, but residual is the observed minus the predicted. Observed is what actually happened. Predicted is what does my equation predict it should be at 12 months. So observed at 12 months is $34,000. Now, how do I get my predicted? Well, I take my equation right here, and I put in a 12. And I type that into my calculator, and I get 33.5092. Now, my observed and my predicted should be pretty close. Remember, we had a high R. So this data is very well correlated. So those two numbers should be in the ballpark. Subtract them, and I get my residual to be very small. Okay, now, what does this mean? Okay, well, let's look. First of all, this answer is positive. Positive means the observed is bigger than the predicted. That means what she's or he is actually getting paid is more than what we predict they would pay. So 1, 2, 3, because it's per thousand, this person is actually making $490.80 more than what this equation predicts them to make. So you would say the office assistant received $490.80 more than the predicted starting salary. Okay, then G says compute the coefficient of determination and interpret it. All right, our coefficient of determination was 0.817. Coefficient of determination. Okay, our coefficient of determination is not 0.817. That was back from the height of the dads and the sons, sorry. Your coefficient of determination is 0.905. So the R squared that you have on your calculator should be 0.905. Okay, now here's what that means. That means that 90.5% of the variation in starting salaries is accounted for or explained by the linear model relating starting salaries to the number of months experience. I'm going to say it again. 90.5% of the variation in starting salaries, because that's what fluctuates, is their salary. The variation of their salaries can be explained by or is accounted for the linear model that relates these two variables together, which are salary and months experience. Don't try to memorize it. Make it make sense. 90.5% of the variation in starting salaries is accounted for or explained by the linear model that relates months of experience to starting salary. And you've got tons of those in your notes that you can go back and look at. Okay, so that takes us through all of that. And so now, let's see where we are. Okay, an AP exam tip. Be sure you know how to read a computer output. Know where you can find the statistics to answer the questions you might be asked. Much of the information on these outputs is extraneous, not needed, and you will not need this information, nor are you expected to know what it means. It's there to throw you off just for kicks. Okay, here we go. We've got manatees versus registrations. The regression equation, all right, it gives it to us right here, and it does not define any variables. It uses what the variables represent. So that's my slope. Slope is always going to be next to the word that it's next to in your equation. Y'all see that? Registrations, and there's your slope. Your constant, which makes sense if you think about it, is going to be your y-intercept because it's a constant. Okay? So the number beside the word constant is always going to be your y-intercept. The number beside what that variable is always going to be your slope. There's your r squared. Now here's what you have to be super, super careful about. This is my r squared, which means I can find my r by just square rooting that number. But here's the problem. I don't know if that r is positive or negative. You have to make a deliberate, conscious decision when you square root 0.897 and you get whatever your r is, if you make that r positive or negative. Here's how you tell. Go look at your slope. If your slope is positive, then your r should be positive because that means it's a positive relationship. If your slope is negative, your r should be negative. Okay? Well, our slope is positive. So whatever you get when you square root 0.897 is going to be our positive r value. So they don't give you the r, they give you the r squared, but you have the ability to find r. Here we go. A random sample of 15 high school students was selected from the U.S. Census at School database. The foot length in centimeters and height in centimeters of each student in the sample were recorded. Okay, again, constant, y-intercept. Slope is always beside the word. So I would have y hat equals 103.41 plus 2.7469x. X would be my foot length, and y hat, what are we predicting, is our height, predicted height. And there's foot length. Again, there's my r squared. I would square root that to get my r. My slope is positive, so my r would be positive. Right, okay. All right, right there. Manatees. Okay, yeah, we're good. We're good on all that. Okay, this is talking about the residual, the difference between observed and expected, and that the difference is the residual, what we talked about, all that, so you should be fine. Okay, let's talk about outliers and influential points. An outlier is an observation that is surprisingly different from the rest of the data. In other words, an observation that does not conform to the general trend. An influential observation is an observation that strongly affects a statistic. Some outliers are influential and some are not. Okay, so let's look at this. Let's look at this scatter plot. Okay, absolutely no outliers whatsoever. Everything is very nicely uniform. You can tell that my R, this is a nice little point. Everybody see that your R is negative, and everybody see that your slope is negative. Okay, so that's all business as usual. Everything is good. Now let's look at this guy. This guy is an outlier because do you see this massive gap that's in between it and the rest of the data? Now, it's not going to affect the slope or the placement of the line of best fit. So it is not influential. No, sorry. Let's backtrack that. He is massively influential. Okay? Let's if we're far away horizontally this way, then you're going to be influential. Because what if he was, I don't know, here? Then he would pull that whole line this way. Or let's say he was way down here. Now he's pulling the line this way. So when you're far away horizontally, you have a lot of weight with the line. But if I'm far away from the line vertically, I'm not going to pull the line. He's pulling the line a little bit down, but not tons, because I've got all these other guys who are kind of holding it steady. So it's an outlier, but it's not an influential because it's not far away horizontally. Again, go back and look at this one. If he's far away from the group horizontally, he is influential, because this line has got to go way out here just for that one point. So again, if he was up here, it would really affect my line. But if I'm just an outlier vertically, I don't have that drastic of a pull on where my line goes. Okay, the last thing we need to talk about are residual plots. Plot of residuals versus the predicted values of y's. This used to assess the fit of the model. I don't know if you guys remember, but when you plot your residuals, you need to make sure that there's no pattern in your residual plot. You want it to be completely random. If that's the case, then if you have a pattern or trend, then the linear model is not appropriate. It's not a good fit. You want your residual plot to be totally random. If that's the case, then you're good with your linear model. If there's a pattern, like I think we looked at one that kind of, the residual looked a little quadratic, then a linear model is not appropriate. Okay, so I want you to practice finding your residual plot. So you're going to go to Stat, Edit, L3. You're going to go to List. Under Names, number 8 is Residual. So you're going to put that gets all the differences. That gets all these numbers and puts them all in your L3. Then to graph, turn your stat plot on, but you only want L1 and L3. You want your L1 and your L3. And go zoom 9, and you should see your residual plot. Okay, so practice that. Make sure you can do that, because you may need to create that on a free response question.